Welcome to my YouTube channel, A Binary of Civil. Today I am going to solve the fifth assignment of Geotechnical Engineering 1 or Soil Mechanics. The first question is, as per Bosniak's theory, the vertical stress on soil, which of the following statements is correct? So, there are two types of theories, Bosniak theory and Westergaard's theory. Regarding Bosniak theory, the first question is, which of the following statements are correct? So he has given four statements. So the applied load is line load. No, Bosniak's theory is applied for the point load which has to be placed on the ground surface. Okay, so the applied load is a point load acting on the ground surface. Okay, so option C is the correct answer for question number 1. Next question. Sigma V is the vertical stress at depth equal to Z, vertically below the load in the soil due to surface point load Q. The vertical stress depth equal to 2Z, vertically below the surface load is. So now we need to have a formula proposed by Bosniak, that is sigma Z is the vertical stress at any point Z below the ground surface is equal to 3Q by 2 pi Z square 1 by 1 plus R by Z whole square whole power 5 by 2. So from this expression, sigma Z is inversely proportional to Z square. So that is sigma Z1 by sigma Z2 is equal to Z2 by Z1 whole square. So he has given sigma Z is the vertical stress at depth Z. Now we need to calculate the vertical stress at depth 2Z. That is sigma Z2, sigma Z1 is sigma V and sigma Z2 is sigma Z2 we need to calculate, and Z2 is 2Z divided by Z whole square. So from this expression you will get sigma Z2 is equal to sigma V divided by 4. Okay, so it is 0.25 sigma V. Okay. So the answer is B for question number 2. Coming to question number 3, the vertical stress at the some depth below center of 3 by 4 rectangular footing to certain load intensity is 150 kN per meter square. Now the vertical stress below the center of 6 by 8, first of all he has given it is 3 by 4. So the vertical stress intensity is 150 kN per meter square. Now coming to 6 by 8. So this is 3 and this is 3, this is 4, this is 4 and it is one more 3 by 3, 4, 4. So this entire thing is 8, this entire thing is 6. It is 6 by 8 rectangular footing. Now he has given at this center, he has given at this point. So it is 150. So it is 150, it is 150, it is 150, it is 150. So 150 into 4 you will get it is 600 kN per meter square. Clear? So the answer is B for question number 3. Now question number 4. A concentrated load 300 kN acts vertically at a point on the soil surface. If Bosniak equation is applied for computation of stress, then ratio of vertical stress at depth 3 meters and 6 meters respectively, he has given sigma Z. We know already sigma Z is inversely proportional to Z square. He asked us to calculate the ratio of vertical stress at 3 meters to 6 meters. So sigma 3 divided by sigma 6 is equal to 6 by 3 whole square, that it is 4. Clear? Answer C for question number 4. Coming to question number 5. For a circular loaded footing with pressure intensity, that is Q, he has given 150 kN per meter square and diameter D is equal to 3 meters. When diameter D is 3 meters, radius R is equal to 1.5 meter. For a vertical stress at depth 5 meters below the center of the footing is, actually you can see here, there is a circular footing. So we need to calculate the vertical stress at any depth Z. And here the load intensity is Q. Now sigma Z at any depth Z is equal to Q into 1 minus 1 by 1 plus R by Z whole square whole power 3 by 2. Okay, so now substitute the values in the equation. So sigma z is equal to Q is 150, 1 minus 1 by 1 plus R is 1.5 meter, Z is equal to 5 meter whole square whole power 3 by 2. So you will get it is 18.2 kilonewton per meter square. Clear? So the answer is D for question number 5. Now an isobar is a line which connects all the points below the ground surface at which. Now isobar is the line joining the points of equal vertical stress. So isobar is the line joining the points of equal vertical stress. Okay, so the answer C for question number 6. Coming to question number 7. For a raft of size 30 by 12 loaded with pressure intensity Q is equal to 200 kilonewton per meter square. The vertical stress in kilonewton per meter square at 20 meters depth below the center of raft by assuming rectangle as equivalent circle. That is, he has given the loaded intensity in the form of rectangle, but he assumed, that is, we need to convert that rectangle into circle. So first of all, rectangle area is 30 by 12. Pi by 4 d square is the circle area. From this we will get d is equal to 21.41 meters. So now the rectangular loaded has been converted into circular loading. So now earlier in the same type of problem we have used the circular equation. So sigma z at any depth in the circle is equal to Q into 1 minus 1 by 1 plus R by Z whole square whole power 3 by 2. So now Q is loaded intensity is 200 kilonewton per meter square and 1 minus 1 by 1 plus radius is equal to 21.41 divided by 2. So you will get it is 10.7 and depth is equal to Z is equal to 20 meter square whole power 3 by 2. So you will get this is 62.9 kilonewton per meter square. So the answer D for question number 7. Coming to question number 8. So a system of isolated footings. So he has given 4 isolated footings. Now we need to calculate the pressure at the center of isolated footing. So by using, this is applicable by using Bosniak equation. So first of all we can calculate the effect of this one isolated footing at the center. So this is 2, this is 2, half. So this radius R value here we will get it is root 2 square plus 2 square. It will be 2.83 meters. Clear? So sigma z is equal to 3q by 2 pi z square 1 by 1 plus R by z whole square whole power 5 by 2. So 3, that Q value we need to substitute. He has given the loaded intensity as 300 kilonewton per meter square and area of footing is 1.8 square. So you will get it is 972 kilonewton. So 3 into 972 is the point load. 2 pi z square is at depth 3 meters into 1 by 1 plus R by z. 2.83 divided by z is equal to 3 whole square whole power 5 by 2. So that is equal to 10.50. So because of one footing the effect is 10.50. Now there are 4 footings. Into 4 you will get approximately 42. So the answer is, the nearest value is 45. Answer B for question number 8. Now coming to question number 9. So this is the last question for the assignment. He has given the standard net new marks influence shot is shown in figure. The loaded, if loaded equally, areas 1 and 2 yield pressure at the center. So the basic principle of Newmark chart is Bosniak equation. From the Bosniak equation Newmark has developed a chart. That chart is Newmark chart. In Newmark chart all the areas will exert same pressure at the center. So that is 1 and 2 yield the same intensity of vertical stress at the center. So option C for question number 9. Thank you.